For today's video, we're going to be taking a look at an agentic framework or kind of workflow from Microsoft, and it is called OmniParser. However, there is an additional thing that we're going to be taking a look at that works in conjunction with OmniParser, which is also from Microsoft, and that is called OmniTool. So really for today's video, we're going to be taking a look first at OmniParser, which is basically a way to actually draw bounding boxes and things like that over screenshots, which will allow a vision language model to kind of have higher success rates in terms of navigating around a computer autonomously. However, OmniTool is almost sort of like a back-end integration for this, where we can actually go ahead and control a Windows 11 virtual machine with the bounding box capability of OmniParser, as well as a vision model of our choice. So this is kind of a really cool little ecosystem that's built right here that allows us to actually have the full agentic workflow running on our machine with a virtual machine running Windows 11. Now, to get this out of the way first and foremost, and something that is unfortunately perhaps kind of a bit disappointing, as it currently sits, you can see that this is actually set to be able to use some OpenAI models, DeepSeek R1, Qwen 2.5 VL, or Anthropic computer use. However, all of these are not like, you might see this and be like, oh, I can run this with Ollama. And unfortunately, that's not currently the case. However, it is my intention to, after today's video, which is just kind of going to be an overview and seeing how this works, likely with GPT-4o, I will start probably right after this video trying to just fork this to actually work with a locally run version of Qwen 2.5. And I do want to make note also that it does say DeepSeek R1 right here. However, if we go and look at some of the actual code behind the agent running and things like that, when DeepSeek R1 is mentioned, it does actually refer to it in the code as DeepSeek R1 Distill Llama 7db. So just in case you were curious about like, well, DeepSeek R1, obviously there are a lot of folks ascribing labels to different variants of distilled models and things like that, saying they're DeepSeek. So it does seem that this is the one that is used. And pretty much as that intro is out of the way, we are going to just go ahead and actually begin by installing and setting up OmniParser, which is really extremely easy to use, and this can actually be run locally. It is the OmniTool kind of back end with the actual agent and virtual machine that for now requires a kind of cloud-hosted AI to actually run. But fingers crossed soon it will not. So if we scroll down right here, just to give a little background on what we get started with, which is OmniParser, we can see in technical jargon terms, it is a comprehensive method for parsing user interface screenshots into structured and easy to understand elements, which significantly enhances the ability of GPT-4 to generate actions that can be accurately grounded in the corresponding regions of the interface. Basically, as we will see, it can take a screenshot, identify every element on that screenshot and put a label on it and things like that, which will better allow a vision language model to actually be able to select an element. So we will basically just jump into it right now, and it is really quite simple to get OmniParser set up and working. And while it is not as important for today's video, since we are just going to be testing this with a cloud-hosted LLM, I am using the Acer Nitro 17 laptop that I have, which will actually be utilized graphically for the OmniParser test that we will do. So as promised, I will just kind of put the information for this specific laptop on the screen here. And this does seem like it will work on Windows or Ubuntu or Linux, but I am going to be testing this on Ubuntu today. To get started installing OmniParser and getting a quick look at it, we are going to begin by simply cloning this GitHub repository, which we can do by clicking the green code button right here, copying the HTTPS URL right here, and then typing git clone in our terminal, and then pasting it, which will clone it into an OmniParser directory on our local machine. Once that's done, we can just scroll down here to the install section in this README, and really it is very, very simple to install this and play with it, which is nice. And we will just begin by creating a new Conda environment named Omni using Python 3.12. Sorry if my hands are like moving weird. It's kind of awkward with this laptop. And I will just type -y on here as it just automatically selects yes to all the questions it would have asked me otherwise here. Once that is done, we are going to activate the Conda environment. And when we have done that, we are going to go ahead and actually change our directory into the cloned OmniParser directory. Once we have done that, we are just going to run pip install-r requirements.txt, which will basically just go ahead and install some of the necessary dependencies to actually run OmniParser into this Conda environment. Installing the requirements did take a good bit of time, as most of them were not cached on the system, since this is the first time I'm actually running this here. However, once that's done, we only have one remaining step, and that is to ensure that we have the weights for the OmniParser V2 model installed in the correct location. And in order to do that, we simply just hop on down here and run this command, which we can do all at once. And again, depending on network speed and things of that sort, this may take a little bit of time. However, these are not too large, so it shouldn't be too long. And once the weights have been installed and placed in the correct location, which that command will automatically do, we are basically all set to actually go ahead and try OmniParser V2, which again will basically draw bounding boxes and labels around a screenshot from a graphical user interface. So in order to run it, we just pop down here to the Gradio demo section, copy this command, paste it into the terminal, ensuring that we are in the correct directory, and this will basically go ahead and start the Gradio web app, which we will then be able to go ahead and actually click on. Now, one thing I do see that I think I don't quite like is that I do believe this will open it with a live shareable URL as well, which basically means that anyone who had that could access your specific system from the World Wide Web. So that is a little kind of, I always like when the Gradio demos are set to default, not have the share option turned on so that it only shows you a local link, but that is a really easy thing to fix. So I did just want to kind of nitpicky point that out. And we can see that it will take a little bit of time to get set up and running for the first time, and we can kind of let it go. And once that's done, we will have our URL to click on and be able to play with this. As a quick addendum, we can actually see that when we ran the Gradio demo for the first time, it actually did go ahead and download some more things. So that is just something to take note of. It did really not take too long at all, but we can see that we now have the local URL for this, as well as the public URL, which again, I'm not kind of the biggest fan of, but so be it. So if we click on the local URL right here and we open it, we will be brought to the Gradio web interface for OmniParser V2, which we can see right here. Now, really, this is quite simple to actually use, and I will just demonstrate that real quick here. So I have taken a screenshot from the GitHub repository right there, and you'll have to apologize. I have to apologize. The mouse is backwards, so it's kind of hard to use this computer. But if I drag this in right here and place it, we will see that this will be kind of a perhaps more robust test, because there are a large amount of elements here, and we're really just going to kind of go ahead and test this. So if we have our screenshot dragged and dropped in and we click submit right here, we will basically see. And keep an eye on video RAM as well here, because this is a laptop 4060, so it only has 8 gigs of available video RAM. But even with the overhead from OBS screen recording running, I only saw maximum utilization of around 3.3 gigabytes of video RAM. So not too bad at all. And we can see here in our image output, unfortunately, it is kind of a bit hard to see. Let me full screen the browser window here, which may help a little bit. But it draws the boxes along with numerical labels and things like that around pretty much everything that it identifies as a specific kind of individual item on screen, if you will. And we can't see that done here. It did do the whole screen, which is really cool. And what I mean by that is this was a very long screenshot, and it did kind of annotate and draw around the entire thing. Perhaps not perfectly. However, there are some settings here that we will actually be able to play with to make some modifications to things. And again, we can see the parsed screen elements get output here as well, where basically it just kind of lists what it is. It gives it an ID or an icon number or things like that. And it actually does transcribe some of what it sees as well. So I've taken a few screenshots from a different device just kind of so we can get a better feel of how this works and hopefully have some more legible output than this gigantic screenshot here. However, I do quickly want to touch upon what these specific items are right here. And really, in order to do that, I think we should just look at this gradiodemo.py script, and hopefully they will be commented in there, and that will tell us kind of what those do. So if we look at the script here and we scroll down, we should see hopefully some comments. All right, awesome. So box threshold label sets the threshold for removing the bounding boxes with low confidence. So that would be this right here. So removes boxes with low confidence. That's the threshold for that. Following that, we have the IOU threshold, which is the threshold for removing the bounding boxes with large overlap. Default is 0.1. Okay. And finally, okay, we don't actually have a comment for the final option there, which is the icon detect image size. So basically, from my understanding, this is how finally it will process the image, or at what size it will actually process the screenshot. So I would assume that a larger size will perhaps put out more fine detail. However, it could also be more computationally expensive, if you will. And also we have this right here for use paddle OCR, which does it. Okay, it doesn't really say what that is, but I would assume we do want that, as it likely gives us better character recognition capabilities. So now let's just throw in some of these screenshots and see how it works. The first one is basically just a screenshot from a Mac with the applications window open. So there are lots of small little icons there that hopefully we'll be able to test it to see how well it identifies and labels those. First, let's just take a quick peek at the screenshot so we can see this is what it is. And it is from a higher resolution screen, so we can actually go ahead and likely up the icon detect image size as well. However, first and foremost, I just want to try this without doing that, and we'll see. So video 2 gigabytes, and unfortunately, this got killed. Our connection timed out. I'm not quite sure why that happened. Maybe it does that automatically if it takes too long without actually doing anything. So I'm just going to run it again. And then once it starts up and we see that URL, we will likely just be able to refresh this page and continue where left off, hopefully. Cool. So let's just go ahead and drag that back in and try one more time. Wow, that is... You know, I'm going to download that so we can get a better look at it first and foremost. So we can see this is really how this works. So this draws boxes with numbers on them around pretty much everything it sees as an individual element. And we can see it has done quite a good job. It did seem to miss a couple of the icons right here. So I think what I want to do is actually go ahead, and we can also see that we have the parse content right here, which just basically will actually list a lot of these application names, and we can see we have FaceTime, Dictionary, Siri, Keynote, GarageBand, etc., which are Mac applications. So if you're not familiar with some of those, don't feel bad because they're kind of Mac specific. But what I do want to do is run the same one through again, and let's put this icon detect image size all the way up, and then we'll see if these 3 in the corner here actually get identified. And I also want to see if that changes video RAM usage. No, not really. Okay, so again, I'm not I mean, I didn't write this software, so I can't fine-grain say what all those options would specifically do, but we can see that it seems to have done kind of a similar thing on first glance. Perhaps you may have been more keen-eyed and noticed a difference that I didn't, but I suppose we can just put that back. Let's see. Let's just play with these randomly. Why not? And then I'll try a few other screenshots real quick in quick succession with this. All right, and we can see that definitely did make some changes, because I can see here first and foremost that far fewer of these are actually drawn boxes. So we can see the labels are, but like a lot of these icons had boxes around them prior to changing some of those other values. So they definitely do make a difference. I am basically just going to go ahead and revert these all to the standard value, and we will just quickly try these other screenshots. So this one right here is not quite a spreadsheet, but it is basically a kind of way to test its ability to look at, I suppose, different shapes and labels and things like that. So I am interested in seeing how this one goes. Wow. Okay, so we can see basically all the boxes that are drawn here are fairly decent. I see it missed a few. However, this is still, I mean, this is a very busy screenshot, I suppose you could say. So that is quite cool. We'll just kind of hop into the next one, which was a more like spreadsheet kind of thing. This is a default thing from the Excel app on Mac, which is called Numbers. So if we just click submit here, it is an attendance sheet that we are going to be taking a look at here. So we can see it before real quick. So this is basically what this looks like. And I want to see what it does with all of these individual cells here. Okay, so it kind of omitted actually looking at those individually. However, we can see that it got a lot of the boxes around numbers and labels and things of that sort. So that is pretty cool. And we will move on to our final one, which is just an eBay search result for Toshiba Quasmios, which of course are my favorite gaming laptop from a more vintage era. And this is just kind of to see how it would do navigating around a web browser or something like that, which obviously a lot of the use case for this would likely pertain to autonomously browsing the web. And here we can see it has really done a fantastic job. I see that it does seem to have pretty much selected everything that was possible to be selected, except the Firefox thing right here. But that's I don't even know if that's clickable on the actual Mac. I don't actually remember. So this is really quite good. So you can imagine if you had it browsing the web and you wanted it to say click on this one right here, it would know, okay, I'm going to click on item 16 or so. And hypothetically would work. So that is really going to conclude the first part of this video, which is just taking a look at the OmniParser V2, which is kind of one of the backbones of what we're going to take a look at now as I close out of this GitHub repository. And we can basically quit this for now, because when we go and actually want to set up OmniTool, it is kind of, I won't say difficult, but tedious perhaps. So there is a bit more setup involved in actually getting this running, but we're just going to run through it together here and see how to get it working. And we'll be able to then play with the little Windows 11 virtual machine agentically. So let's go ahead and jump into setting up OmniTool here, which as we can see consists of three components. One is the OmniParser server, which is basically what we just saw, where OmniParser V2 is running so that it can annotate and draw boxes around the screenshots. The second is OmniBox, which is a Windows 11 virtual machine running in a Docker container. And finally, the third is a Gradio web UI to provide commands and watch reasoning/execution on OmniBox. And really what that means is it's just a Gradio web interface where we can actually see OmniParser server and OmniBox interacting together. So we'll basically be able to see what the virtual machine is doing, how it's thinking, and what actions it is performing based off of what we tell it we want it to do. So with that out of the way, we can basically jump right into getting ahead and doing this. I do want to note that you actually are going to need to download a Windows 11 disk image from this, which is around 5.5 gigabytes, I believe. And then when it builds the Docker container, I think you're going to need somewhere around 20 gigs of free space or something like that. So if you do want to do this, make sure you have a lot of free space. Fortunately, the Windows ISO file comes directly from Microsoft themselves, being that this is a Microsoft repository, so it is cool. You do have to provide your info, which I mean you can do if you want, but yeah. So we're basically going to jump down here into the setup section right here, and I'm going to pretty much ignore the notes right here for now because I'm going to be running this all on the same machine. But you can see that they do mention running these perhaps on some different machines, which I suppose could be a use case, especially in a local setup. So if I do successfully fork this to run locally, this could become more of a consideration that As we see the setup section here, we can see that we already do have the Conda environment for OmniParser set up, and we can basically jump to G right here where it says continue from here if you have the environment. However, we also already did actually get the V2 weights downloaded, being that we did basically go through the homepage setup for this for OmniParser from this repository. So this I think is more pertinent if you perhaps had downloaded OmniParser prior to the introduction of version 2 and wanted to go ahead and play with OmniTool. So assuming you followed along with the same steps that I have up until this point, we can basically ignore step H here as well. However, we do want to now run step H again down here, which is a little confusing. And we are just going to type cd omniparser/omnitool/omniparser server. And we can see there is no such file directory because I was in the wrong home directory. So you want to run that from your home directory, which if you type pwd would just be home/your username. And if we paste that in again and run it, we will see that it brings us into that actual location where we need to be. So the next thing we're going to want to do is actually start the server. However, I'm going to pause on doing that right now because we need to actually get the Docker image and download ISO file set up and everything like that. So we're going to hop into actually doing that right now. The next thing, and something I'm not going to cover right here because there are a lot of resources for having this set up and things like that, is to have Docker desktop installed on your machine. A lot of folks are perhaps polarized opinion-wise on Docker. I myself completely understand that viewpoint, but assuming we do have Docker installed and set up on our machine, the next step is to actually visit this Microsoft Evaluation Center, accept the terms of service, and download a Windows 11 Enterprise Evaluation ISO. So if we follow this link right here and we click it, we do need to register for our free trial today by filling out this form here, entering an email. And from my understanding, you don't actually need to confirm the email once you've entered it. So make of that what you will. But once we do this and we click the download now button, we will be brought to a page where we can then go ahead and actually download the correct disk image. So once we have entered our info and selected the blue download now button, we will be brought to this page where we can then select our download. And for what we're doing right here, the one we are going to want is the first one right here that says English United States. And we do want the 64-bit edition. We do not want to click on the ARM64 edition or this ISO Enterprise download. So we are just going to click this right here and it will go ahead and actually download this disk image to our machine, which we can see is 5 gigabytes and will take a little bit of time depending on your network speed. So once the Windows 11 disk image has completed downloading, we basically need to first begin by renaming it to custom.iso, and then we are going to copy it to the directory in this location. Now, to be honest with you, we can do that programmatically through the terminal. However, I think it might just make more sense to do all of that through the File Explorer instead, as it can just perhaps be a bit simpler. So in our downloads folder, we are going to navigate to the location of this download, which for me is just right here. And you can see the name is quite cluttered. So I'm just going to click Properties. And again, if you're on Windows or something, this process will differ slightly, but we just want to basically delete everything prior to the period ISO there, and then type custom instead to name it to what they have defined us to name it as. And once we have done that, we are basically going to copy it to the directory right here. So I will just kind of make a new file browser window, and that directory is from our, where are we? Right here. Sorry, I'm not used to browsing through the File Explorer. So from the OmniParser directory, we are going to go to OmniTool. And I'm just following along with what we see right here. So in case you get a little lost by my messy file explorers here, I apologize. So we go to the OmniParser repository that we cloned. From within there, we click the OmniTool folder. Then we click the OmniBox folder. Under the VM folder or virtual machine, we will see a Windows 11 ISO folder, which is right here. And if we click on this, it only has a readme.md in it. So In here is where we want to place this custom.iso. So we will just basically drag that in from our downloads folder or wherever it is, ensure that it is correctly named to custom.iso, and then we can go ahead and actually close out of right here. So the next step is actually going to be to build the virtual machine using that disk image. And from there, we do need to actually go to a different directory. So I'm going back to the terminal here. I apologize if that was a little confusing, but hopefully it makes some level of sense. So from the OmniParser directory, we are going to go to OmniTool, OmniBox, and scripts. And from within there, if we type list, we will see there are a few different options. And for what we are going to want to do, we are going to run /manage_vm.sh space create, which will go ahead and, as it says right here, it will store a save of the virtual machine. Well, it will create it and then store a save of it, etc. So it basically sets up the Docker Windows 11 virtual machine with the downloaded disk image. All right. Now that we have our ISO downloaded, we are basically going to be able to go ahead and actually build this Docker container. So we have made sure that we renamed it to custom and moved it to the correct directory. And now we are going to run this command right here to actually change our directory into the OmniTool/OmniBox/scripts location. I am already in the OmniParser folder, so I will just run it cd from here on, which will put us into the correct location. And from within there, we basically go ahead and build the container by running ./manage_vm.sh space create, or just copy paste that command. And then once we do that, it will take a little bit of time, but it will actually begin to create the Docker container with Windows 11 in it, and then we will be able to go ahead and actually agentically play with it, which is pretty cool. And we can see image not found locally building, which is normal, and this will basically take a little bit of time. And yeah, once that's done, we move on to the next step. Now, shortly after we run this for the first time, we will kind of see this message repeating where it says waiting for a response from the computer control server. When first building the VM storage folder, this can take a while. So this is normal. Don't be concerned. Depending on the speed of your disk and things like that, it will take a little bit of time. So it is, I kind of wish there was a little more feedback to let you know, like, hey, it's doing this. This is what kind of step it's on percentage-wise. However, we just kind of get this until the container is built. And then upon the completion of the container being built, we will actually be able to see it launched. All right, so as this can get a little like concerning, like, is it working? Is it not working? One alternative thing we can do to try to give ourselves some estimation of like what % complete this is actually run the following command right here, which basically every 10 seconds will update the size of this Windows 11 storage, or kind of like the Docker container. So basically, as this number continues to grow, where we just saw right there, went from 15 to 16, then we see, okay, this is actually working. It is kind of doing its thing with the container, and there is no cause for alarm. So that is just kind of something to keep in mind there. There are ways to kind of give ourselves a sort of shortcut to making sure that this is actually making progress. And once that finally completes, we will see a message here that the VM plus server is up and running, and it will return us just to our prompt. So once the Docker container is successfully kind of set up and everything, we can now go ahead and actually get to trying OmniTool. And it does become a little confusing here, I find, because what we're actually going to need to do is run all three of these things at the same time. So we have one right here. So we need to run OmniParser server. We need to run the Docker container with the Windows 11 virtual machine. And we need to run this Gradio web interface here so we can actually interact with the kind of whole agentic functionality here, and that will also give us visual feedback so we can see what it's doing. And from the Gradio web interface, we can also prompt it with what we want it to do. Now, essentially, we just need to have 3 terminal windows open here to actually go ahead and do this. So I'm just going to follow along with these sequentially to get all of the necessary things set up and going. The first one we can do is just start OmniParser server, as we see right here. So we are just going to navigate to the directory locating right here. So we can paste that in. And we will start the server right here. However, if I were to just start this right now, you will notice that there is going to be an error where it says there is no module named Fast API. And the reason for that is because you also need to make sure that in each of the new terminal windows you open to actually kind of get this going, you activate the Conda environment that we had created earlier on in this video. So we are just going to do Conda activate, sorry for my one hand slow typing, Omni. And then once we do that, if we enter the command once more, and if you want to cycle through previously entered commands, you can just use the arrow keys. So we'll run it right here, and we press enter, and we didn't get an error, so that will actually go ahead and start the OmniParser server. Now, while that is going, we can go ahead and begin the Docker virtual container, whatever you want to call it. And all we need to do, because I'm still in the directory that we had actually set up the container with, so I'm still in the same directory where we ran the manage vm sh create command. So from within there, we can basically just go ahead and run this command, which will start the virtual machine. Make sure, if you see, this is actually spread across 2 different lines here, so make sure you don't omit the / before pasting this in, or else it will cause an issue. So, okay, we can see that it is started and waiting for a response from the computer control server, which is probably this, hopefully. So finally, our next step is to actually go ahead and start the Gradio server. So from a new terminal window, we are just going to navigate to this location. And again, don't forget to actually create the new Conda, activate the Conda environment. And then once we have done that, we are going to start the server just by copy pasting this command right here, which should hopefully, fingers crossed, spin up a nice little Gradio web interface where we can then go ahead and actually play with this agentic OmniTool thing. Not thing, but you know what I mean. So, all right, we can actually see that right here where we have Windows 11. Let me expand this a bit. So this is actually our Docker container that we made, and this is really quite cool. I do believe, can we navigate around in this from within? Is there like a human interactivity thing? Okay, I don't actually know, but let's just play with this real quick. So we can see this is kind of our main point of access for actually controlling the OmniTool agent. And we can see that we have some different model settings here. So basically you can go and select any of the models that we kind of saw were available to us earlier on in this repository guide video, whatever you want to call it. So I am going to be using GPT-4o, so I will leave that the same way. And being that that is the case, our API provider, of course, is OpenAI. And I now need to enter my API key in, which again is a separate thing from ChatGPT subscription. So you would need to go and actually set up an API key with OpenAI. And that is something that costs money, but for small experimental purposes like this, relatively speaking, it really is like a negligible amount of money, like less than $1 for kind of just playing with it. So once I have my key, I'll paste it in there. And then basically we can go ahead and actually send a message to OmniParser and our kind of whole agentic system here. And the message, of course, will be telling it to actually do something. So let's just go ahead and have it open Google Chrome and search for a MacBook Air. I have no idea. And assuming everything has been set up correct, we will press send. And we will see that kind of these scripts here are going ahead and functioning. And remember, this is at this point not really running locally because it is using the GPT-4o model to actually do this. But we can see that it lists the steps here. The OmniParser is running locally as we saw before, but the actual like backend for the LLM is, of course, OpenAI right now. We can see that it gives us nice output along with kind of some annotated screenshots as we saw before from OmniParser. So it gives us an analysis, basically like, okay, this is what I need to do. This is what I'm going to do. And then basically it will keep making screenshots and seeing them and saying, okay, it seems like this has happened, so I need to go ahead and do this. So we can see, okay, the Google Chrome browser is now open. To proceed with the task of searching for MacBook Air, I need to bypass the sign-in stage and proceed to the browser interface. I will click Don't Sign In. And then, of course, we see it's selecting the box ID 8. So that's one way that, like, having just such high-quality kind of bounding boxes with labels and things like that really helps guide these models to actually do the right thing. And it will do coordinates here so it knows where to click. It does seem like it may have gotten a little confused. So it's basically realizing that it's getting tripped up by the enhanced ad privacy in Chrome. It's going to need to figure out, hopefully, to go ahead and click the got it there. Okay, and it gave us an error. So let's just say, let's change this to search for a MacBook Air. And again, I'm not going to spend really too much time showing this functioning because one, it does get expensive if you play with it a lot, and two, it is more just kind of the videos about like showing how to replicate this and things like that. And also I really want to get this working locally with hopefully the 7 billion parameter version of Qwen 2.5 VL, as of course then it's offline and free and all the good things we like. It is really cool to see all these agentic things coming out, and from what I've seen, a lot of them function in similar ways, just kind of like this. The ByteDance UI-TARS desktop that I had featured a couple weeks ago or a week or two ago kind of worked like this. Okay, so we can see this is just not really working too well, so I'm going to stop this. I wonder if I can actually go ahead and take charge here. I should be able to here. Yeah, okay. All right, so we've given it kind of a multi-turn prompt here, I suppose, if you will. I'm going to go ahead and actually clear the history, and we will send that. So we are telling it finally to close Chrome, make a new desktop folder, named folder. I know, very creative, and then open it. So we will see kind of what it tries to do here. I do kind of wish this pane right here in the chatbot history was a bit bigger, but then again, I do suppose being able to see this perhaps may be more prudent, but this is a Gradio app, so it would be pretty easy to modify these. I'm about to have this thing just open up Task Manager and force quit Chrome that way. All right, well, this isn't working too well, but it is kind of disappointing because I really did, I had this working better earlier. I got it to open GIMP. I suppose that's kind of a simple thing akin to having open Chrome. So that really is going to be it for now, because this was just more of kind of a demonstration tutorial how to install this and get it running. Again, I'm not as interested in playing with something like this too much when it is hooked into a paid API service like it is right now. So really, the thing to do is to now try to go ahead and actually fork this just to work with a local vision model, which I don't think should be too much of an issue having looked through some of the code. Of course, we always kind of assume perhaps things are going to be less difficult than they end up being, but knock on wood, it shouldn't be too bad. So that's really going to conclude it. When I saw this, I was really impressed with it, and even just OmniParser by itself, because I really do see a lot of very cool use cases for having something powerful like that that runs locally that can do a very coherent job of annotating screens with bounding boxes, label IDs, and also some pertinent information about what the actual things on the screen say. So that is probably going to conclude it. This is absolutely not the last that we will see of this on the channel, so hopefully it is something that folks are interested in and want to see more of. And yeah, again, if you have any questions, please feel free to leave them in the comments, and thanks for watching. That's going to wrap it up.